Now let's talk about data models for NoSQL. In this class, we will cover three different types of data models: key value stores, extensible stores, and document stores. The first one, key value store, is quite simple. Everything is stored in key value pairs. That's it. No tuples, no columns. The key in each key value pair must be a unique identifier, such as a string or an integer. And the value, on the other hand, can be anything: a number, a string, or even a picture or a video. And we only implement two operations in a key value store: getting a key value pair given a key, or storing a new pair. Nothing else. All other functionalities must be implemented by the application that interact with it. Why are we doing this? Because now we can easily distribute the key value pairs across multiple machines. Just use a hash function on the key and distribute the key value pair based on the returned hash value. Similarly, we can also replicate a given key value pair by running its key through multiple hash functions. And getting and putting these key value pairs are also very easy. Just call the hash function and go to the appropriate server in the case of a get. We don't need to worry about contacting multiple servers to retrieve data for a query, because the only thing that we can do is get on a single key. Again, no joins, no aggregates. So let's see an example. Suppose we have a flights dataset consisting of individual flight and carrier information. We can either store each flight's ID as the key and the rest of the data as the associated value. Or we can key on each flight's date and store everything else that happened on that date in terms of all the other flights as its associated value. Or we can even use each flight's origin and destination together as the key and store everything else as the associated value. I encourage you to think about how query processing will work under these different options. For instance, if we want to look up all flights that go from Oakland to New York, how would we do it if data is stored under option 1, say compared to option 3? Which one will be more efficient? As I said, inside a key value store, we use a hash function to determine which server a key value pair should be stored. And if we want to replicate, we just use multiple hash functions to decide on which set of servers to store a particular key value pair. If we do that, there is a potential issue with propagating rights to all the servers that are supposed to store a given key value pair. But that's okay, since remember, under NoSQL, we only provide eventual consistency. So the application itself will need to handle stale reads if it somehow cannot tolerate those. Hence, key value stores typically use both partitioning and replication to scale up to handle large number of clients. And doing all this at the expense of limiting functionalities provided to applications and also potential consistency issues. Now let's talk briefly about extensible record stores. These are also called wide column stores, with Google's Bigtable and the open source HBase project being representative implementations. Extensible stores provide two data models. The first one is just like key value store, with what we call a row ID and its associated value. And just like key value stores, each row's associated value can be completely different. For instance, one row might store a student's picture as its value, while another row might store flight data. The second data model is more restricted. We now assume that the value stored in each record actually consists of a bunch of columns, just like in a relation, rather than random bytes. So now we can reference the stored value using a combination of row and the so-called column IDs. For instance, looking up using a student ID and a semester value, say spring 2021, will return all the classes that the given student took in that particular semester. We can pass in even more columns as part of the key as well, and as you can see, this is basically a way to implement more complex lookups beyond just using the row ID in a get operation.